Hello everyone. So in this video we are going to do this question, the problem number 28 in the series of problems you must try. So the question says that there are 34 roots of this equation, and this equation we can see is a very giant one that starts from 1 and goes up to 34 with the degrees of x, and the coefficients are running from 1 to 3 up to 17 and again decreasing like up to 18 and again decreasing till 1, and denominator is x to the power 17 and right hand side is 1. And how the zk is defined, the zk, the k is a subscript for rk, means maybe the magnitude of each complex root will also change according to this information we have. The k value 1 will give you the r1 and so on, and the argument runs like 2 pi alpha k, and alpha has this criteria, means so alpha 1 is lesser than alpha 2, means whenever you get the alpha values and we have to rearrange them in the increasing order, the first value will be known as the alpha 1 and so on. What we have to evaluate after finding all these values of alphas, we have to only select the first 5 and find the sum of those first 5 and multiply by 2 pi, and whatever the quantity will appear, we have to take the greatest integer of it. So our prime aim is to find out the solution of this equation, and from there we identify what the values of alpha will take. So if you want to give a try, of course you should. So pause the video here and try to solve this problem, and if you solve it correctly, your answer should be 3. So now we jump to the solution and we will see how we can manage this situation. So first of all, try to identify this thing, that this equation, whatever we have given, can be rewritten as this one. You can notice if I divide x to the power 17 to each of this numerator, I can group some terms, like x to the power 34 will be divided by x to the power 17. So we get x to the 17, and again this I take it with 1, so I group them as x to the power 17 plus 1 by x to the power 17. Similarly, if I group with the coefficient 2, I can see that 2 times x to the 16 and 1 by x to the 16. Similarly, we go up to like 3, let me write 3x to the power 15, 1 by x to the power 15. And you notice finally what we get at the coefficient of 1, we get here that x to the power, coefficient 1 already getting. So we are here now 17. So 17 to coefficient 17 we get as x plus 1 by x. And also notice there is only one term which contains the 18 here. It means when we divide by this, that will term only be 18 here, and the right hand side I have 1. And denominator already we have managed, so there no need to write it. All right. Now you notice this interesting fact that x to the power 17, 1 by x to the power 17 plus 2 times this bracket plus this bracket plus 17 times this bracket, and again I can write that 17 is equal to 0. Now you identify if zk is the root there, you notice that the z to the power 17, suppose I'm taking this way, that this zk is taking its root, so zk to the power 17 and 1 by zk to the power 17. But when you are adding them up, we are getting right hand side as 0, which is real number. Now you notice if I'm taking any complex number here, this 1 by zk will be the reciprocal of it, and if reciprocal, the this each bracket should give real so that I can add all the reals to get real on the right hand side. It means that I have the complex number and its conjugate pair will be there in each bracket. Then only the complex number imaginary part with its conjugate imaginary part will get cancelled. What does it mean? It simply means that suppose I'm taking this situation like a complex number z with r cosine theta plus I sine theta, and suppose I'm taking its reciprocal 1 by z, that is 1 by r cosine theta minus I sine theta, and you are intended to add them to get the right hand side 0. Of course there is 17 there, so I need to have this 0 or the real quantity. So real quantity means z plus 1 by z. It means I will have r minus 1 by r sine theta at the imaginary part. So I write there imaginary part of z plus 1 by z is this one, and that is must be 0. Then only we get real number. Now if this is real, sorry, this is 0, what does it mean? It means that either r minus 1 by r is 0 or sine theta is 0. Now if sine theta is 0, the theta will be 0, and it means that the complex number is purely real. But it's not the case, because the complex number can be real only in two cases. When I take the r is equal to 1 by r, it will give you the r is equal to 1. It indicates that whatever we are intending for the rk for each complex number magnitude, the magnitude should be 1 only. Each complex number magnitude should be 1. It means rk is 1. If rk is 1, my complex number will look like zk is equal to e the power I 2 pi alpha k. Now for the purpose of convenience, I am assuming this theta k is equal to 2 pi alpha k. And if I find the theta k, of course I can find the alpha k as well by equating. So this one important thing we cracked, that the rk must be 1 due to this fact that the complex number I am assuming it's not all real complex numbers, means not all real numbers. There are some complex numbers which has imaginary parts. So this is valid only if I have r minus r 1 by r is equal to 0, because this case I cannot take for all the complex numbers z. Therefore r minus 1 by r should be 0, and which gives you r is equal to 1. We can also see later that why this r is equal to 1 by r should be giving r is equal to 1, or directly how can we think that the magnitude should be 1 only. So this is the first part we cracked, and it takes to this thing. The second thing is also very crucial. Let me copy this thing, and let me copy this entire thing here. So what I mean to say, let me explain. So idea is this: observe the numerator here. The numerator what I have is 1 plus 2x plus 3x squared plus 18x to the power 17, 17x to the power 18, 18x to the power 19 plus dot 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 2x to the power 33 plus x to the power 34. Now the numerator is very important series, and it's very interesting also. How this 2x will be achieved? You notice that this 34 can be achieved by taking the, by the way there is a dot dot dot, you understood, by taking the square of x to the power 17. So what I'm guessing, let me just take the guess, is that this numerator is nothing but the square of this series 1 plus x squared plus x cubed till x to the power 17. And how I can confirm that it is going to be, let's see. If I square, it means that you are actually multiplying this two series together. Means single series twice, 1 plus x squared plus x cubed and x to the power 17. Now how we can guess, means how my guess was correct. Let's see that if I multiply 1 in 1, I get 1. I get 1 into x and then x into 1, so we get 2x. Now there is no other way to get 2x. Means this is the only two cases. It means the 2x will be achieved by 1 plus x. 2x will be achieved by 1 and x, and then x and 1. So I need these two things. Similarly, to get 3x squared, I will have 1 into x squared, then x into x, and then x squared into 1. So we get 3x squared. So for each next term, I need some previous. Forget the 3x squared, I need 3 terms here. Forget again 4x cubed, I get 4 terms, and so on. To get this total, I need this thing. So you can notice that how we can confirm that 18 x to the power 19 is also we are getting. So of course, this is our 17 is here, then 2 is here, 19, and so on. So it's not hard to analyze that this is going to be the case. So once we crack this thing, our entire expression for the left hand side of this equation will turn into what? 1 plus x squared till x to the power 17 to the power 2 and divided by x to the power 17, and that is equal to 1. I can also write, if you notice, that 1 plus x, this is a geometric series with the common ratio x, and so we can write 1 minus x to the power 17, rather 18 because 18 terms are there, and divided by 1 minus x. And here I can write x to the power, by the way, square of it, x to the power 17. Now we know that this has the root zk, and since I know that now the rk is 1, so I can write directly e the power I 2 pi, and remember I have assumed this theta k here, this 2 pi alpha k, I have assumed that theta k. So I substitute this thing there directly and we'll solve it. How do we solve it? Let's see it. I'm substituting this x with e the power I 2 pi theta k and divided by the way, this is 18 there, and 1 minus e the power I 2 pi theta k, not 2 pi theta k. Why I have done a mistake here. This is 2 pi theta k, I have assumed 2 pi alpha k, I have assumed theta k. So my life will be easier. So that will be theta k only, not 2 pi. Okay, so this is theta k, and this is also e the power I theta k to the power 17. Now, and this is square also, no problem. Now what we can do, I am taking the magnitude both sides because I'm willing to find out theta values, and further I will use it for finding the alpha. So I'm taking magnitude both sides. So what we get it here, the 1 minus e the power I, and this is 18 there, so 18, so this is e the power I 18 theta k, and divided by e the power of 1 minus e the power I theta k magnitude, and here also the magnitude of this. So this is square, by the way, and here or the magnitude if you take, you will, okay, so let me write first, so that then magnitude. Now it doesn't matter what will happen for this angle and anything, it will turn into cosine of 17 theta k plus I sine 17 theta k. So this magnitude will be 1 only. And now since we are taking the magnitude complex number, we take the square root. So what I'm getting here is the 1 minus e the power I 18 theta k magnitude divided by 1 minus e the power I theta k magnitude, and that is equal to 1. So what I can do now, that I'm going to write this e the power I 18 theta k and e the power I theta k in terms of sine and cosine. So this will give you 1 minus cosine 18 theta k plus, not plus, is minus, because okay, so minus I sine 18 theta k magnitude. And on the right hand side again I get 1 minus cosine theta k and minus I sine theta k magnitude. This will lead us to, now this one I'm writing 2 sine squared 9 theta k, and this guy I'm writing as 2 sine 9 theta k cosine 9 theta k. In the same way I'm writing this thing as 2 sine squared theta k by 2, and this I'm writing as 2 sine theta k by 2 into cosine theta k by 2. You may understand what I mean to say that. Now I can take this 2 sine 9 theta k common, so we get my magnitude here, and whatever left out here I'm getting sine 9 theta k minus cosine with the I 9 theta k, and here also I'm getting this 2 sine theta k by 2 magnitude, and again I have this sine theta k by 2 minus I cosine theta k by 2. Now it doesn't matter what this I will put, the sine 9 theta, cosine 9 theta, so this will give you the magnitude 1, and this will give you also the magnitude 1 because this is the mod we are finding. It means we are left with only this equation, sine 9 theta k magnitude or the mod is equal to sine theta k by 2 mod. Now we have to deal with this trigonometric equation in two different cases. So first I'm taking case 1, like sine 9 theta k is equal to theta k by 2, sorry, sine theta k by 2, rather sine theta k by 2. Now this is I'm taking positive, and I'm taking sine of x is equal to sine of alpha. So since the sign here is a positive sign, it means this we can write generally as sine theta k is equal to, in the first quadrant if I'm intending, so I write 2n pi plus theta k by 2, because when you add even pi to theta k by 2 will lead us to first quadrant. Or the second case, this is second sub case, I will have either you go in the first quadrant by adding even pi, or if you go in the second quadrant by subtracting this theta k by 2 from odd pi. So 9 theta k, and we can write 2n plus 1 pi minus theta k by 2. In this way I can directly find theta k. So what you get theta k in this case is, you notice 9 to the 18 minus 1 17 theta k by 2, and that is going to be 2n pi. And now it's the time to substitute the theta k value what I have assumed earlier, that is 2 pi alpha k. So what I'm getting here is 17 by 2 and 2 pi alpha k, and that is 2n pi. So this is 2 pi and 2 pi get cancelled, so we get alpha k is equal to 2n by 17. We just leave it like this. and see what will happen. Similarly, for this case, what we get, you notice now this time this will be added, so we get 19 theta k by 2, and that is 2n plus 1 pi. Again, this theta k, I am writing this 2 pi alpha k, which will cancel this 2, and so I am getting here that alpha k in this case is the odd pi by 19. Notice one thing, this alpha k, don't think that this is not dependent on n. The alpha k are the values of those alpha you are finding on n. So this k is a subscript only for the counting of the number of roots and also deciding the increasing order. Which means that when we say alpha 1, it means we are finding the first smallest value on just giving the integer values to n, and all are positive, because you can notice that the alpha k is lying between 0 and 1, so all are positive, and so we cannot put n is equal to negative negative integers. Now this is the first case we got. Now what about the second case? Second case, I'm taking case 2, when I have sine of 9 theta k is equal to minus of sine theta k by 2. So this is a negative, by the way, so again two subcases will have, so I will write sine of 9 theta k, and that directly write, not required this thing. So first case will be when this a negative sign happens, so let me write it. So theta k, if you take the odd pi, it means 2n plus 1 pi, we have to add it because we will jump to the third quadrant, and from there again you get here, you can notice that theta k is equal to 2n plus 1 pi by I think 17, because no, this is 2 will left out here, 2. Now theta k, I'm writing this 2 pi alpha k, and this 2 will get cancelled. So what I'm getting is here is pi also cancel, so alpha k is equal to 2n plus 1 by 17. Now you notice that combining this alpha k, which has the denominator 17, these two values, I'm getting that one case in which alpha k is all the positive integers times 1 by 17, because when you put n is equal to 1 and 2 and all these integers for n, this will give you even numbers by 17, and these are giving odd numbers by 17. It means alpha k in this first group is what? This is 1 by 17, 2 by 17, 3 by 17, and so on. Similarly, if you take the second case for this, second sub case for this case, here we get all the even. Let me demonstrate. So what we get it here is 9 theta k is equal to 2n pi, and this time negative, so minus theta k by 2. And notice again 19 will come denominator, so I'm directly writing alpha k is equal to the even pi by 19 you will get if you simplify that. So the second case, what we are getting is, the second group, what I'm getting is 1 by 19, 2 by 19, 3 by 19, 4 by 19. Now notice what we have to find out. We have to find out 2 pi and the summation of this, all this k goes from 1 to 5 and alpha 1 till alpha 5. It means since I'm writing in increasing order, because they are already giving the subscript are in increasing order, so the value of the alpha are also increasing order. So we have to choose first 5 alpha values out of these two groups. So I think the first number you can choose is alpha by 19 because it is lesser number. So that is going to be 2 pi. 2 pi is the least number is this one. So I'm writing 1 by 19. Now notice the 2 by 19 is also lesser than 2 by 17. How you can know that? You notice that here I can multiply. So let me do 19 in all the numerator. The first group I'm multiplying 19 in all the numerator, and denominator also I'm multiplying the same thing, but denominator will become 19 by 17, so I'm calling it some number, let's say p, and this will give you 38 by p, and that will give you 57 by p. Similarly, in the second group, I am multiplying the 17 and 17. So 17 by p, because again the denominator will become 19 into 17. And this is 34 by p, and this is 51 by p. So now it's easy to guess that what are the three numbers. So this is 17 is lesser than 19. So this one, then this one, then this one, then this one, and this one. It means the first 3 in the 19 series and first 2 in the 17 series we are getting. So this is 1 by 19, 2 by 19, and 3 by 19, plus 1 by 17 and plus 2 by 17. After that, I don't think there's a need of my calculation, but when you calculate correctly, you will get the greatest integer of this entire quantity as 3. I don't know why this 2 pi is given here. Just to confuse, even that was sufficient to give the answer 0. Maybe they want the numerical integer as a non-zero value, that's fine. Okay, now there's one more important thing I wanted to convey here, that why the magnitude of this complex number for all Rk is 1. One method I already explained here, so maybe it's not so convincing, but let's try to understand here. You notice that in this equation here, suppose I'm taking, which one I wanted to say, let's say this one I'm taking, and we try to understand why the Rk is 1 only. So see here, if you assume that the magnitude of x is greater than 1, in that case what will happen, that this geometric series I can write as what? 1 plus x square till x to the power 17, and again we have to square it, and that is x to the power 17. Now you can assume that if any number the magnitude is greater than 1, and this I can write, or maybe let's say right here this way, 1 plus x square x to the power 17, and here I can write x to the power 17 by 2, so it's convenient. Now here, since I'm considering the magnitude of it, so and each of them are the complex numbers, so here I'm going to apply the triangle inequality, so I can write 1 plus x square till x to the power 17 is always lesser than or equal to magnitude of each quantity, so mod x plus mod of x square plus mod of x to the power 17. Now, and you can also write this as mod of x to the power 18 minus 1 by mod of x minus 1. If mod of x is greater than 1, this entire value will be greater than the very large number compared to the number what we're getting here. Means if you take the magnitude both sides like this, so this magnitude will become 1 only, and if you take this entire magnitude, this quantity magnitude is still lesser than this, but this quantity will be very large compared to this one when I take the magnitude of x is greater than 1. It means that the magnitude of x must be 1. It means each complex number magnitude should be 1 only. Then only this question can be solved in this way. So I hope it makes sense. So far whatever I have worked in my little time, this solution I found means I come up with this thinking, and this is my solution to this question. In further, I cannot promise, but further if I get any other easy solution for this, I will definitely explain it in some other video. So see you in the next video with some other problems that I think you must try. Till then, stay math active.